Hello, everyone. Great to be here. I'm Kirk Borne, and I'm here today at this Data Science Industry Applications Conference. Hopefully, it's been a good conference for all of you. I'm here today to talk about 1,001 things to do with your data to achieve analytics mastery. Now, that's the advertised title. I decided to throw another buzzword in there, free. Oh, is that a buzzword? Well, sometimes it is. But you'll see what I mean as we get into the talk. What do I mean by free things? But the focus is on how can we use our data across different industries and different business applications to basically achieve maximum value and maximum sort of return on the investment that we put into our data assets. And believe me, we've all put investments into our data assets. So those who know me perhaps know that I used to be at Booz Allen Hamilton. I was the principal data scientist, data science fellow, and executive advisor there for several years. Just recently, I moved to a startup, DataPrime. I'm the chief science officer of a startup. So we're just getting underway with this. And so the goal of DataPrime is really to help data scientists and data professionals of all kinds, data engineers, data analysts, business intelligence specialists, database engineers, any data professional to be matched to the right jobs. And so it's really a tool primarily for hiring managers and recruiters, but the way it's going to work is when people upload their data profiles into the platform. And so it's really about finding value in your own data. That is your data about who you are, what your skills are, what your experience is, what your interests are. And even though you may not be looking for a job today, if you upload your profile at dataprime.ai, so maybe someday this year, next year, this week, next week, who knows when, some candidate profile of yours may match a pretty good job description somewhere out there, and you might get a call. So it's not a jobs board. We don't have jobs there. It's really ultimately a platform to build a community of data scientists, and in doing that, we're bringing value from data. And so that leads me to really the punchline of today's talk of describing who are we anyway. So we're here today to learn about data science and industry applications, but our purpose really is that we are entrusted with our organization's massive data assets, or you may just say digital assets, and from those to discover insights and deliver value from these data. So this is what we're asked to do for our businesses. They may not put it in these words, but ultimately at the end of the day, this is what people are looking for, that insights, discovery from all this data and value from all of this data. So I'd like to point out that there's sort of 5 dimensions to analytics. And we've probably seen some aspect of this previously, and I have a certain take on it myself personally. And that is, these are 5 dimensions. Sometimes it's called 5 levels of maturity in analytics. And I don't like to say it's maturity because it sort of gives the impression that you have to move up the ladder, but you can keep doing different parts of these or different dimensions of analytics at different times. They don't always have to be like in a progression. For example, descriptive analytics is basically hindsight, looking at what happened in the past. And often that basically means just asking the required questions. Like, how much did we sell? How much revenue did we make? How many customers did we gain? How many customers did we lose? Things like this. And so descriptive analytics oftentimes is satisfying business requirements, whether it's regulations or compliance, even from the government, that you have to do certain kinds of business reporting. So descriptive analytics can sometimes be the most critical in terms of the legally binding thing you need to do with your data. But of course, we want to go beyond just looking into the rearview mirror, seeing what happened in the past, and looking more to the present and to the future. So diagnostic analytics is the next level up, which basically we do sort of real-time oversight of what's happening now, or in some cases, sort of why did what's happening right now. And so hindsight to oversight is the first 2 dimensions here. And then the third, I would say, step or dimension is foresight or predictive analytics. So predictive analytics does tell us not what happened in the past or what's happening now, but what will happen in the future. And oftentimes in business, this is sort of like what's considered advanced analytics. That when you're doing predictive analytics, you're doing advanced analytics. And that's conditionally true. Conditionally, there's more beyond that. But beyond that, if you're not doing beyond that, then at least you're getting that advanced stage of where you're looking into the crystal ball, if you will, telling the future, which is makes data scientists look like magicians at some point. And so what goes beyond that? Well, beyond that is prescriptive analytics, which is basically saying when you build a predictive model and you don't like the outcome, what can you do to change it? So you explore your data. You explore data for insights that can tell you how to change the outcome. What are the causal variables, the causal factors, the things you can do to change an outcome, to optimize an outcome? So that's basically insights discovery, finding what those causal features are and causal factors are that you have control over. So prediction is great if it's a good outcome. It's not so great if it's not a good outcome, like predicting customer churn or something bad will happen to like a machine in a shop or a jet engine on a plane. You want to do some preventive or prescriptive maintenance on those things to prevent the thing from happening that you don't want to see. So I call that insight. So we've moved from hindsight to oversight to foresight to insight. And at the fifth level here, or the fifth dimension, I call it right sight, just because it sort of rhymes with everything else, but for a reason, because it's really about getting the full 360 view. It's really looking at all of your data in the same way a human is a very cognitive human if you take in the full context of something before you make a decision. You don't look just straight ahead when you're driving. You take into context what's going on around the car, around the vehicle, around the environment, children playing on the side of the street, things like this. You take the full cognitive view, and that allows you to do the right thing, take the right decision, the right action, in the right context at the right time. So I like to call that right sight. But what's also special about cognitive analytics also is the other very human aspect of it is humans are very good at questioning things. Like when you see something that looks peculiar or strange, you say, well, why is that? What's this all about? And so it moves beyond just answering the questions that you're provided, which is what descriptive analytics is. And you can think of cognitive analytics as the exact opposite of descriptive. That is, it's finding the new questions in the data. Instead of just providing answers, it's about providing questions that you should be asking your data. Like, why is this trend here? Why is there suddenly this outlier here? Why did this customer segment go away, or why did this customer segment appear? And we had a lot of that going on in the last year with the COVID pandemic. There were a lot of new trends in data, whether it's consumer data or work data or business data, just from all the things that changed in the world, working from home and all those things over the past year. So really cognitive analytics and descriptive are opposites. But again, not to say that one is better than the other, even though if you want to have that analytics maturity, it certainly is more performant to do the predictive, prescriptive, and cognitive analytics steps here. So these are things we're doing with our data to achieve business outcomes. As mentioned in the last slide, the majority of businesses have for a number of years thought of advanced analytics as being predictive. And you'll see a lot of cases in this slide here. So here's a slide from several years ago that talked about different applications of analytics in business and in specific sectors, as you can see listed here. And I put around certain words there, a red box. So those red boxes are my addition to this slide. And all those things in that slide are either predictive or prescriptive analytics. That is, they're trying to predict something or to optimize something. So, forecasting or optimization, basically, in all of these things. So even a recommender engine is a prediction, right? You put a recommendation on a website when you're selling certain products, and you put a recommendation there because the goal is you hopefully the person will accept that recommendation and purchase that product or purchase that service. And so you're making a prediction that the thing you put there is going to have the optimal outcome for your business. You're not just putting some random thing there, you're putting something that you really think this customer might be interested in. So in some senses, both predictive and prescriptive, and it's based upon prior data that shows that customers who bought similar things might also buy this new thing. So predictive analytics is pretty much everywhere, and we're seeing more prescriptive analytics, that is optimization, taking place as we realize that once we start predicting things, we may not like the prediction. So let's see what we can do to change it by getting those insights from the data that show us what the causal variables are that could lead us to making changes. And so in the medical world, it's called in clinical analytics. It's very common in medical and clinical analytics that you do the traditional A/B testing on medical trials to see whether a treatment works. So you have a treatment sample and a control sample, the A group and the B group, and to see whether a particular treatment has the desired effect, or if it just has no different effect from a placebo that is a non-treatment. And so doing these kind of things in business, you might think of like recommendation engines as some sort of a version of clinical trials, but for recommended products instead of medicine. Excuse me. So now we get to the free things you can do with your data. And I mentioned the word free as a sort of a buzzword when I started. And the reason is because of course, it's not free. I mean, you spend money collecting data, you spend money building data systems, data access systems, data engineering systems, machine learning systems, and so forth. But what's free, what I mean by free is that once you've collected data, you can reuse the data. It's a renewable resource. It's not like oil, right? So people say data is the new oil, and I think that's like the worst analogy ever because oil, once it's used, it's done. You can't reuse it. But data can be reused over and over and over again. The same customer data can be used for recommender engines or for customer care or for new products and new services or trend discovery or market intelligence, all kinds of applications from the same data set. So those things are essentially free in the sense that once you've spent the money, you invested to collect that data, maybe for the first application that you were using it for, you now have a bunch of other applications you can use it for. And so this particular slide here has an eye chart. So don't try to read all these words. I'm not going to try to read them to you. It comes from an article that I wrote, a blog that I wrote on with exactly this title, 1001 free things you can do with your data. And there's about 150, 160 things listed there. So you might say, well, that's not 1001. Well, the number 1001s come from something I remembered from my childhood. I remember seeing advertised in the children's magazine that I had as a child. I can't remember what it was. Probably Mad Magazine, if anyone knows what that was, or maybe it was Boy's Life, or whatever. And they had these advertisements in the back, and you could get this list of 1001 free things. And the list was free, and the things were free. So I ordered the list, and I was amazed. I mean, you get all kinds of little maps and booklets and all kinds of stuff, stamps and coins. I mean, it was just, for me, it was an eye-opening experience. I just had a blast ordering, just at the cost of a stamp, just free stuff. And of course, my parents were wondering, well, what is all this stuff coming in the mail? But nothing more than the cost of a stamp. And so I said to myself, well, this is sort of like our data. We can do all these things with our data. So the 1001 comes from that backstory of mine. But the reason it's also 1001 is not an unreasonable number, because each of the things listed here, there are many different sort of industry applications of that thing. So let me give you an example. So we'll pick one of those things, which is predictive analytics on streaming business data. Okay, so that's like one thing on that previous slide. And here I list 15 use cases of that one application. Okay, so these 15 use cases represent many different ways to use your data for this particular type of thing, predictive analytics on streaming data. Okay, not just predictive analytics on static data, but streaming data. And so if you think about each of those things on the previous slide that I said there might have been 150 or 160 or something like that, things listed there, and you multiply it by some number like 10 or more or less, I can see where you can get close to 1,000, if not well over 1,000. So what are these things here? Let me just read through a few of them. Again, I'm not here to just read to you, but to give you a chance to sort of see what the words are besides listening to me talk about the words. So real-time credit risk prediction, real-time fraud risk prediction, real-time personalized customer interactions, real-time context-specific and location-sensitive product or content marketing to consumers, do not pay classification on fraudulent insurance claims prior to payment. This is a really big one in government. Real-time determination of benefits eligibility prior to actually giving the benefits in order to mitigate underwriting fraud. Detection of insurance rate evasion tactics, optimal actuarial price determination and policy quoting, and so forth. So you can see a lot of things going on here, including healthcare and cybersecurity, data breaches, funds transfers, various business transactions, supply chain, warehousing, and so forth. So these are all applications of predictive analytics and streaming business data, which is, again, just one application, but 15 use cases of that. So I put together another eye chart for you here, and I'm not going to be able to go through all of this, but the good news is that I've been told that you will get access to these slides once the conference is over, and I did give permission to share these slides, so you will be able to get these slides. And so I list here 20 or more industries and verticals where an article describes data science, analytics, and AI use cases in that sector, in that industry, in that vertical. And so if you're interested in one specific thing, you can just click on that one, or if you're looking for several of these, you can just click on those and see what various use cases and applications there are in those specific industries and verticals, whether they're specifically relevant to you or you're looking to discover more about what other industries are doing. So I should have prepared you. There are eye charts galore on this slide deck. But again, because you have access to it later, I hope this is beneficial to you as a resource later on, even though we may not be able to read through everything today. So I found this other article, not one that I wrote, like the 1001 things. This was the 10 common uses for machine learning applications in business. And so in yellow here, there's these specific applications, and then there, or I should say techniques, and then there's in white sort of the application. So for example, real-time chatbot agents, or conversational AI. Okay, so what we're seeing here in terms of the actual algorithms, it's natural language processing, natural language understanding, that's NLU, natural language generation, that's NLG, which altogether gives us conversational AI. And the applications we see in customer service and call centers, financial services, voice assistants, which many of us use. So that's just one thing, sort of one general area, and the specific types of algorithms and the specific business applications. And you can read on down the list. There's decision support. And decision support comes from these predictive and prescriptive insights that we get from our data, whether it's through dashboards or modeling or traditional business intelligence. And of course, the applications are in every type of sector there is. Customer recommendation engines, which again can be both predictive and prescriptive. It's personalization. It actually uses also sentiment analysis at times. Customer churn modeling, dynamic pricing, market research, customer segmentation, fraud detection, image understanding, operational efficiency, and information retrieval and extraction. Excuse me. So this is from this other article, 10 common uses of machine learning applications in business. And I want to focus on one specific thing here on the next slide. And the specific thing I just want to focus on, just picking one out, and that's natural language processing, or what I rather call document processing, or AI-powered document processing. So this is a subtle but very powerful, in this case, business use case of analytics. And why I say subtle but powerful, because oftentimes we think of document processing or text analytics as basically sort of like a keyword search, right? So you search for documents that are on this particular topic, but it can go way beyond that. Okay, so from the previous slide, there was these 10 machine learning applications in business, and at least 5 of the 10 things on the preceding slide have some application of AI-enhanced document processing. So in decision report, market research, fraud detection, operational efficiency, and obviously information retrieval. And the use cases are quite interesting in that, and I just list some here, which are from the fields of marketing, medical, legal, contracts, and claims. For example, content summarization, actually using AI to summarize what's in the document. That's called document understanding. So it's not just keywords you're searching for. You're trying to find documents that have a particular kind of content or even a particular type of sentiment. Is it positive or negative about this particular thing it's talking about? Document categorization, it helps us to sort it. Document classification, that helps us to label it. I mean, not just simple labels that you might just like the title or the abstract, but more deep labeling of what's in the document. And then actually discovering entities in the document, people, places, things, brands, products, discovering entities, extracting those, and if there's any kind of like numerical value associated with number extraction, actually extracting numerical values if there are such things about the entities, or even finding the relationships and links and associations between those entities that are listed and mentioned in the documents. Insights discovery for decision support, of course, like in market intelligence. And then, of course, we have to mention key phrase information, that is retrieval and extraction, finding the key phrases in the document. Link analysis, which is this graph-based e-discovery. So very important in the legal profession. And even identifying logos, okay? So identify particular types of graphics in documents is valuable also. Logo detection and extraction, and people are actually doing these things. So I mentioned sentiment analysis, but also if you have like a sort of a temporal sequence of documents, you can do trend analysis. For example, quarterly business reports. You can do trend analysis, not just on numbers, but even on the sentiment or the topics being discussed in a particular business report. Okay, so the quarterly reports can give you a lot of insight into what businesses are moving into, whether they're moving away from, what's being productive for them and what's not. So all these things on this one slide here are just that one application of AI enhanced document processing as a business application. So while we're on this discussion of massive data and data all over the place, let's not forget about the Internet of Things, especially the industrial Internet of Things, because the edge at which the sensors are collecting data, it gives us what's called edge intelligence. And so this edge intelligence can power businesses at the competitive edge, not waiting to bring the data back to your system, store it in a data warehouse, and have your data science team analyze the data in the data warehouse over a period of days, weeks, or months. You want to get this real-time insight as best you can. And so this edge intelligence can really power your business at the competitive edge. And this is a really big deal. There's been a lot of studies about sort of what the anticipated business value of the Internet of Things, the sort of the revenue projections for the coming 5 years or 10 years. And it's oftentimes measured in the trillions of dollars. And these are different reports, but you can see the numbers are measured in the trillions of dollars. And the specific thing you do with the data is you compute on that data at the edge. So we call that edge computing. So the Linux Foundation has another sub-foundation called the Edge Foundation, and they did a report that estimated that the sort of the business market for edge computing could reach 800 billion, or at least close to $1 trillion within the next decade. And another article, I really love the quote they said here: IoT companies will dominate the 2020s. Is your resume ready? Whether it's your personal or business resume, data is coming from sensors everywhere. So I like to say that the internet used to be a thing. Now things are the internet. That is to say, we have it on homes and cities and energy, on healthcare, wearable devices, defense applications, retail applications, just about everywhere. So all these data by themselves would be valuable just for their sort of singular insight about that particular sensor at that particular location. But what I like about it is it gives us context to our other data. So I like to call the Internet of Things now the Internet of Context, because it provides this contextual data that powers that cognitive analytics I talked about earlier. Other data about your data, other data about the thing that you're paying attention to, like a customer or a product or a service. What's going on in the market, what's going on in the world, what's going on with the weather, what's going on in that place at that time. This contextual data from the sensors is powerful for your cognitive analytics, for the best value you can get out of your data. And there's a couple books here that I just mentioned. I have no connection with these books other than I found them very interesting. One called The Age of Context, and the other one called Outside Insight. Okay, so this contextual data from external sensors, that's the outside insight, and that gives us the context that powers this age of insight and context. So context will be everywhere because sensors will be everywhere. Context to infinity and beyond. Okay, I don't think they actually said that in the Toy Story movie, but I thought it was pretty cool. So I want to sort of wrap up before a couple more things, and then we'll be done with this. So 3 more slides and then the final slide. And one of these things I want to just mention is that sometimes people think of Internet of Things only in terms of monitoring something, right? You put a sensor just to keep track of it, to keep an eye on it. But it can be way more than just monitoring. It should go beyond that. Because if you just deploy sensors everywhere, what do? You get a data deluge. Okay, so I say, ouch here. If you just get more data, what good is that? You don't need more information. What you really need is more insights. And that's really the emphasis today on how to bring value to your business, is find those insights that give you both predictive and cognitive discovery in your data, so you can take the right actions at the right time and build your business up. So what you need is more insights. That's the truth. So consequently, what I would say is smart IoT deployments are essential. So what do I mean by smart? Well, various things can be mean by smart. I mean, cognitive, contextual, predictive, but also in terms of the business sense. They are smart in the sense that they're informed by deliberate decisions about where and when you need more insights in your business. Where do you need more insights across your enterprise? So that's a deliberate decision should be made of how you and where you deploy these sensors. And they're also strategic because they should be designed or deployed to meet desired outcomes, that is mission objectives, right? So you don't just put them there. You have a reason you're putting there, and hopefully it's to meet some desired outcome or mission objective. So in order to make it smart, therefore you need a strategy, and I like to call that an observability strategy, in order to deliver those mission critical insights as a service at the place and time you need it. So when I talk with people, they often say this is just monitoring, right? And I want to just differentiate it. Maybe this is just me here, but hopefully this is a valuable differentiation. That is, monitoring is what you do, sensors are how you do it, and observability is why you do it. So the observability is the why, answers the why question. Why are you doing this? So when the senior executive or the board of directors or shareholders say, why are you doing this? I mean, you hope you have a good answer for why you're doing this. And that goes back to those smart deployments, the informed decisions, the strategic decisions. So observability strategy gives you the why answer to the question, not just what you're doing and how you're doing it. So insights from the data are the rewards for doing this. And so that's your big reward at the end of the day. That big analytic reward is the insights you get. And if you're really clever, you can then attach APIs to these sensors so anybody can subscribe to the insights. Okay, so and of course, I was just talking about sensors as providing context. So think about this providing context as a service, or even insights as a service. And those APIs, people can subscribe within your organization or even outside your organization, and you can build a business model around selling access to insights as a service to external partners. That can be part of your observability strategy. So here's just 3 things. I mean, we saw a list of 10 things, 1,000 things. We've seen many different lists today. Here's just 3 things you can do with insights as a service at the edge. One of those things is what I would call sentinel analytics, using sensors to watch the things that should be watched. That's the sentinel. That's the guard on the guard post. That's the sentinel. Watching things to make sure that if things are going okay, you're picking up the good vibrations or not. That is it time to sound the alarm or just to be aware and that you're compliant with whatever things you need to be compliant with. That's sentinel analytics, using sensors and data to watch the things that should be watched. Precursor analytics, that's the early warning signs of risky events. It's like the shaking of the ground prior to an earthquake. You see these sudden changes, drifts, and change points and emerging trends in your data. Oh my. Okay, that could give you early warning or forecasting as a service. And then there's cognitive analytics, which is discover the right questions you should be asking with your data. That's truly cognitive event science. In fact, when you see something in your data, ask somebody about it, do something about it, investigate it. So your STELLAR Analytics Scorecard consists of these 7 steps that spell out the word stellar, STELLAR, STELLAR Analytics. So that's intentional. The numbering you see on the list here is out of order, 1, 2, 3, 4, 7, 6, 5, and that's intentional because I wanted to spell out the word, but the order of progression goes by the numbers. So streaming analytics, real-time interaction and discovery from data, detecting persons or behaviors of interest. Team analytics, that culture of experimentation, diversification, collaboration. That data sharing and data reuse we've talked about with the free stuff you can do with your data. Edge analytics, that's locality in time at the point and moment of data collection. Location analytics is locality in geospace. In that particular context, what else is happening at that place? Number 5, again, going to the bottom in numerical order, related entity analytics, what locality in data feature space. So think about 3, 4, and 5 as the space-time continuum of data. You have a time, and you have geospace, and you have data feature space. What else is like this entity? What else is like this event in my data? That's related entity analytics. Then we have agile analytics, number 6, which is analytics by design, iterative, building proofs of concept, fail fast to learn fast, building those minimal viable products, or I like to say the minimal lovable product. And number 7, the ultimate achievement is a learning business system. Excuse me. So a learning business system is not about training courses. It has nothing to do with training. It has to do with your business actually with continuous feedback, learning, and improvement from data that you access through your normal daily business practice. So you have data-driven knowledge generation from your business processes in order to provide feedback, learning, and improvement. And that's the learning business system. And there's actually a whole field of medicine called the learning health system, where you can see this link here, and there's articles written about that. And I'd say we need to apply this to the concept of business. So this is the ultimate achievement in your business if you have a learning business system and applying your analytics that way. So that's it. Thank you. I say thank you for coming for the data, stay for the science. A couple graphics here I just want to mention, then I'll stop. And that is, on to the left is a book that I'm a co-author of that's coming out later this fall. So you might want to check it out, Demystifying AI for the Enterprise. You can pre-order it now, even though it's not coming out for a couple months. And I love this quote from Isaac Asimov, famous science writer. He said, "The most exciting phrase to hear in science, the one that heralds new discoveries, is not eureka, but that's funny." So I'm wishing you many funny encounters with your data. So thanks for listening today. I know I talked fast, but hopefully these slides will be made available to you soon, and you can go back through it more slowly and peruse the different things I've mentioned here. So thank you all. And I guess if there's time for questions, I'll take them. If we have to move forward, that's okay too.